say that this is less than or equal to 2 power 2 over 2 power k. No. 2 over 2 power k. Huh? And then, okay, I can take the limit and it turns out that this must be 0. Okay? So this is a very difficult calculation. You can try to figure out for yourself. Okay? I'm leaving this for you. But, you know, what does this show is that the measure of this set A is 0. So what next? So how many of people can see this part?
No, sir.
If they can't, then, okay, then let me write it here. So keeping in view this conclusion that, you know, the measure of this set A is 0, I want to argue, you know, that now, you know, sequence found by, so it's like this sequence f and j converges to f almost everywhere actually. So this is what is my next thing that I would like to do. Okay. So if x is not in A, okay, then, so if x is in A, has a measure 0. So I have to just now worry that, okay, what if x is not in A? So if x is not in A, this means that x is not in the union from j equal to k to infinity ak for some k. Would that be true? Because if x is not in this intersection, it's not gonna be in one of these, basically what do you call unions actually. And here's the interesting thing: if x is not in
union,
you know, this union which starts from k, then it cannot be also in
any of the
any of them afterwards actually.
After
Okay.
k.
Okay, so k plus 1, k plus 2 and so on and so forth.
including k also.
Including k also obviously. Okay, for some k, then x does not belongs to
Sir, you AJ thing on sir this.
j equal to, huh? Yes, obviously. J union of j equal to k to infinity, okay, and what? Let me take dot. Okay, aj for all what? And maybe I put an n here, and then I say that this is true for all k bigger than or n bigger than or equal to k. Would that be okay? Okay, this would be okay. And if this is the case, for each such x, what would be true? If x is not in A, and hence x is not in such kind of union for all n bigger than or equal to k, you know, what does this x is? So what conclusion you can have about this x? This means that the distance of f and j of x and f of x is the opposite of what? Opposite of this actually. So it's less than or equal to j. And this is true for all what? J bigger than or equal to k actually. Okay? And this completes the proof, because this is what it shows, that f and j converges to x, okay, for all j bigger than or equal to k. Taken a better. So x is not in A. So x is not in some j equal to k, union of some j equal to k, aj actually. So it's like it's not in union for some k. And then I'm saying that, okay, if it is not, it's for some k, then after this k it will not also be in all of such sets.
So why you did union here?
What
Union.
do you mean by
Union, then x is not in aj for all j greater than k.
can still call their union actually. It's finite. So in other words, if I want to call it CK, then I'm saying that okay, if it's not in CK, then it's also not in CK plus 1 and CK plus 2 and so on and so forth. That's precisely what I'm trying to say. Now I'm asking a question for you. What is the meaning of X not being in this set actually? Then you can also understand this as well. What is the meaning of X not being in this set? What is the meaning of X being in this set actually?
The distance of fn.
Like this is true, okay? This is true actually, okay? And when X is not in this set, then what would be true actually?
Smaller
So
than
what would be the exactly opposite of that actually? Okay? So hence I can say that this must be true for all j bigger than or equal to j. And what does this shows? This shows what does it want actually. So it's like in other words, I can choose any j I want and I can make it small arbitrarily. Okay? So you got the sequence. Okay?
सर जो स्टार्टिंग में हमने कहा ना we can find and वो मुझे समझ नहीं आई बात.
Okay. Alright. So shall I wrap and then talk about it? What was the definition of convergence in magic? Limit. So for a given epsilon positive, limit n goes to infinity mu of the collection of those points for which fn of x minus f of x is bigger than epsilon is 0. This measure is 0. Okay? So I'm calling this number as an actually. Call this number an.
Sequence X.
Okay? So here's the thing. For this epsilon positive, okay? Okay, so that's one epsilon. So I can say that, let me give you another epsilon actually. Okay, this epsilon is for the interior actually. But I'm choosing, so I want to make this number smaller than my choice of number actually. And that choice of number for me is this 1 over 2j. I can choose it.
Sequence.
I can choose it. So it's a sequence actually.
Real numbers.
So I can choose it. So I want to find what? I want to make, this sequence an, okay, smaller than, what do you call,
The previous
1 over j. Okay?
1 or 2 per
The
j.
question is, can I do it?
1 or 2 per j, sir.
मतलब
1 or 2 power j. 1 or 2 power j. Can I do it? The answer is that I can do it. So in other words, एक epsilon यहाँ है और एक epsilon यहाँ है. This is a given epsilon to me. So I can choose whatever I want. And I can make it smaller than any epsilon I want actually. So I'm just making the choice of epsilons. So here I'm choosing 1 over j. And here I'm choosing 1 over 2j. But since I have a convergence, okay, I can always find an instance that, since I have a convergence, I can always do this actually.
Sir, convergence of A is in short.
It's just a manifestation of definition actually. Okay? Just a manifestation of definition. And you will sit back and ponder upon it. So you will make sense of it. Let me prove some things called the Chebyshev inequality. So you might hear this Chebyshev's inequality usually in the terms of the probabilities actually. Okay? The set of probability, because you can generalize it to the general measure. So the lemma says that if p is bigger than or equal to 1 and less than infinity, then the measure of the points for which the absolute of x exceeds a number a, okay, cannot go beyond the integral, okay, of
4 power 1 by p.
d mu not 1 by p, okay, a raised to p, okay. So in other words, the measure cannot go beyond this integral divided by a raised to p. Obviously, you have to assume that a is a positive number, okay. What would be the proof? The proof would be simple. So imagine I have a point x, okay, let x from x be a point for which the f of x is bigger than or equal to a, okay. Then what? Then obviously its pth power will be bigger than or equal to the pth power, okay. You must be happy with this. And then I would say that, okay, f of x raised to pth power by a raised to p must be bigger than or equal to 1. Agree? And if I multiply, okay, let's give this set a name a. Okay? If I multiply both sides by the indicator function of a, then I'm going to have the indicator function of a on this side.
So do we have restriction on A?
I'm sorry?
Restriction on A, like it can be positive or negative.
No.
Negative, then we won't have the inequality.
Absolute.
But we can have, because indicator function is a is either 0 or 1 actually.
Sir, but the first step that you did, the second last.
This one?
Oh, yes, sir.
Why not?
You drew a thing, but the divided one.
No, okay, this is what that I say that let's assume that a is not 0
But positive.
and positive.
Yes, yes.
Okay, it's non-zero and positive. Okay, so
Sorry.
that's not a trouble. So you have this inequality. And once you have this inequality, what you should do, just integrate it. Just integrate both sides actually. So if you integrate both sides, what you're going to get?
This side the required beta.
So on this side you're going to get mu of a. This is equal to what? This would be, okay. This would be,
Integral over a
okay, yes. This would be integral
over
over a
of
of this f of x.
pth power of
Let's keep it abstract. Pth power of a divided by a to the p. Maybe I can get rid of this a to the p here and write a d mu. Okay, so I'm going to get this. But this is bigger than or equal to, or less than or equal to this side, if I integrate it over whole x actually, and I have the same integrand. Okay, f raised to p over a raised to p and d mu. That's what the proof is. That's what the proof is. And as promised, the last proposition is that if you have a convergence in LP, then you have convergence in measure. Convergence in measure. Yes. Okay. Yes. So it will be a corollary actually. So what will be the quickly proof? Just replace in this inequality f by fn minus f actually. Okay? Just replace f by fn minus f. So what are you going to get? So mu of x such that fn of x minus f of x bigger than or equal to a, or maybe an arbitrary small epsilon. Okay. Must be less than or equal to integral of fn minus f d mu over epsilon by p. And since you have this convergence, this goes to zero as well, and then goes to infinity. Okay, so you got the convergence measure. ठीक है जी. So let's do break and then meet again.